Hey there! Let's talk about a topic that pops up on pretty much every science exam, separating mixtures. If you've ever felt a little stuck on this, don't worry. We're about to make sure you are absolutely ready for it.
So, I'm guessing you've got a test on the horizon, maybe feeling a bit of that revision pressure. Well, you're in exactly the right place. We're gonna sort this out.
Seriously, in just the next 5 minutes, we're going to fly through everything you need to know to completely ace this topic. So, you ready? Let's dive in.
So here's our game plan. We'll start with the basics, what even is a mixture? Then we'll tackle different types, solids with liquids, and then the really cool one, how to unscramble the colors in ink. And to finish off, I've got some pro tips that will really make your answers shine.
Okay, first things first, we have to get this foundation right. What actually is a mixture? Right, think of it like this. A mixture is just a bunch of things thrown together in the same space, but they haven't actually bonded to become something new. Like a fruit salad. You've got strawberries and blueberries in a bowl, but the strawberries are still strawberries, right? And that's the key, because they're only physically combined. We can use physical methods to pull them apart again.
All right, let's get into our first challenge. How do you separate a mixture when it's made of two different solids?
Okay, so imagine you've accidentally mixed a whole bunch of iron filings with sand. It's a total mess. They're both solids. How in the world do you get that iron out?
Simple! You just use a magnet. The magnet will literally jump the iron filings out of the sand, leaving the sand behind. Easy! And this isn't just some classroom trick. This is used on a huge scale in recycling plants to pull steel out of all our other rubbish.
Okay, that was a bit easy. But what if neither of the solids is magnetic? Let's say you've spilled sugar all over some sand. A magnet's not going to help you here. So what do you do now?
Well, we can use a solvent. And our go-to solvent is usually just water. You pour water into the sandy sugar, give it a stir, and the sugar will dissolve, but the sand won't. So now you've got sandy water with sugar dissolved in it. And that leads us perfectly into our next problem. How do we get that sand out now?
Which brings us right to our next big question. We've got a solid mixed with a liquid. How do we get them apart? So let's stick with our sandy sugar water. The sugar has dissolved, we can't see it. But the sand is just swirling around in there. It's insoluble. To get that out, we need a technique you will use all the time in a science lab.
It's called filtration. All you do is pour your mixture through some filter paper. The paper acts like a superfine sieve. The water and the dissolved sugar can get through the tiny holes, but the bigger sand particles, they get trapped.
Now, you absolutely have to know these two words for your exam. The sand that gets stuck on the paper, that's the residue. And the sugary water that drips through into the beaker, that's the filtrate. And you see filtration everywhere. It's how we get clean drinking water, and it's even the tech inside things like N95 masks.
Okay, awesome. We filtered out the sand. But what about our filtrate? It's still got the sugar dissolved in it. How do we deal with that? Well, it all depends on what you want to keep. Do you want the solid back, or do you want the pure liquid?
This slide nails the two options. Look at the left side. If you want the solid back, like getting salt from salty water, you just use evaporation. Heat it up, the water turns to steam and disappears, and you're left with the salt crystals. But what if you wanted to keep the water? Look at the right side. For that, you need simple distillation. You still heat the water into steam, but then you capture that steam and cool it down so it turns back into pure liquid water, leaving all the salt behind. It really just depends on what part you want to recover.
Right, time for something a little different. What if you've got a mixture where several different things are all dissolved together in the same liquid? The best example is ink. We all kind of know that black ink isn't really just black, right? It's usually a mix of a bunch of different colored dyes. So how could you prove that? How could you separate them all out?
The answer is a really cool technique called paper chromatography. Think of it like a race. You put a small dot of ink on a piece of paper, and then you dip the bottom edge of the paper into a solvent. The solvent starts to creep up the paper, and as it does, it carries the ink dyes with it. Here's the clever part. The dyes that dissolve really well in the solvent get carried further up the paper, while the less soluble ones get left behind.
And reading the result, the chromatogram, is super easy. If you see more than one colored spot, you know you started with a mixture. If there's only one spot, it was a pure substance. And this is the most important part for your exam. The spot that traveled the furthest is the most soluble, and the spot that barely moved from the start line is the least soluble. Simple as that.
Okay, we've nailed the big ideas. Now let's talk about the little details that will get you those top marks.
These are the things that show an examiner you really know your stuff.
Okay, listen up. These are so important. First, for distillation, that thermometer bulb has to be right next to the entrance of the condenser. Why? Because that's where you'll measure the actual temperature of the vapor as it's about to be cooled, its true boiling point. Also for distillation, the cooling water has to go in at the bottom of the condenser and out at the top. That forces the whole jacket to fill with cold water, making it way more efficient. And finally, for chromatography, you must draw your starting line in pencil. If you use pen, the ink will run up the paper with the solvent and ruin your experiment. And make sure that pencil line is above the level of the solvent, otherwise your sample will just dissolve into the beaker instead of running up the paper.
So let's just do a super quick recap. It's all about using different physical properties. If you've got an insoluble solid, you're going to use filtration. If you want to get a dissolved solid back, that's evaporation. If you need the pure liquid solvent, you'll use distillation. And if you're separating different dissolved substances, like dyes, it's chromatography, which is all about how soluble they are.
And here's a final thought to leave you with. This isn't just stuff you do in a lab. From making a cup of tea to purifying water, these ideas are everywhere. So take a look around you. What mixtures can you spot? How would you separate them? Thinking about that is honestly the best revision you can do. You've got this. Good luck with your exam.